Hey everybody, this is Alex Merced from AlexMercedCoder.dev, and in this video what I want to do is talk about sort of the MapReduce pattern. Now, this is, you probably are familiar with like array methods like map and reduce. But sort of thinking about this pattern got me more thinking when I started learning more about the data world and MPP systems, which are just like multi-processing systems. In the sense that instead of having one computer do a job, you would generally have like these clusters of computers doing a job. And generally the way they work is that generally you have one computer that is the ringleader called the coordinator, and then you have several nodes that the coordinator distributes work to. Okay? And they generally, basically the logic, the high level logic is going to be very much what I'm kind of doing in this video. Just imagine that instead of me doing it the way I'm going to do it is that I'm passing each chunk of work to a different computer, and then, we collect all those pieces to get to the final result. Okay, and the idea of what I'm saying to do is sort of like a divide and conquer strategy. Okay, so what I'm going to do is I'm going to create a new file. So let's create a new file. We'll call it MapReduce.js. And basically the idea is you have a large data set. So we're going to create like an array of 1,000 numbers to simulate like a large data set. So we're going to just say so first thing we'll do is we'll just say const nums equals an empty array. And then we're going to just create a standard loop. We're just going to say while nums.length is less than 100 or less than 1,000. As long as that is true, then what I want to do is say nums.push, and we'll push the length in there as a number. Okay. And then just to kind of test that that worked, we're going to then console.log nums after the loop. Console.log nums. Okay, so let's just run that, just make sure that we create the array just fine. So console dot log, not console.log, node node MapReduce. Okay, and then I got a little error, so let's find out num. Oh, where did I use num? Nums. Oh, right here. Okay, let's try that again. Okay, so cool. So there, I created an array with a bunch of items. Okay, so now what if I wanted to create a new array where each item is added by 1? Okay, let's see how long that would take. Okay, console.log or console.time. Okay, and this is going to be for our basically no reduce strategy. So basically we're literally just mapping over every item. Okay, so console.log. Nums.map. And we're just going to take each item and add 1 to it. Return x plus 1. Okay, so we're just going to go one by one, add console.timeEnd, and we're going to end the no reduce timer. Okay, and then we're going to just see how long that takes. Okay, so it took about 881 milliseconds. Again, this is a small 1,000. Okay, so, but again, that's gonna, if I were to, let's make this 10,000. So let's see here, we'll make that like 10,000 items. Let's see how long that takes. Okay, so see now it's starting to take like almost 2 seconds. Okay. Well, not even. Okay, let's just make that a bigger. Let's make this take a while. Let's see here. That's 1 million. Let's make it 10 million. Okay, so that took about 20 milliseconds. Let's make this. Let's put a 6 here. There we go. Now it's starting to take a little bit longer. Okay, cool. So now it's taking like 1 second. Okay, so we can kind of see a difference in time. So we're generating like a huge amount of numbers in an array, and then we're adding 1 to all of them. Okay, and you see it hangs for a second. It takes about 1 second to add if you're doing it one by one by one by one. Okay, so one way we could speed it up is if we can break up the work. Okay, and say, okay, can we set it up in a way where we can have multiple? In this case, we're probably not going to be able to speed it up all that much because I'm not necessarily really doing multiple threads, but if I can get like the same process kind of happening multiple times. Okay, so let's try to do this with a promise. I'm not quite sure if this is going to do exactly what I want it to do because the more I think about it, you're still working with a single thread. But the thought process would be that you would take, maybe spin up multiple threads or use multiple cores or use multiple computers. The idea is you're going to pass off pieces of the work. So first thing I'd want to do is create sort of an array of arrays, right? Where each array equals a chunk of the data from the original array. Okay, so what I would do first is we would say, let's see here. Okay, let's think here. Well, we know there's 6 million, so we'll just say, or 60 million. So we'll try to create 6 arrays, each of 10 million items. Okay. So what we would do then is we would want to say, I'm just trying to think through like the way I'm going to express this. What I would want to do is say ours, const ours. We're going to create an array of arrays. So we'll start off with an empty array, and what I want to do is just kind of create an array of a bunch of different subsets of numbers. Okay, and what we would do is we would say while, and knowing we have, again, you would want to dynamically like figure this out in a different situation, but I want to keep it simple right now. We know it's 6. Okay, so while ours dot length is less than 6. Okay, what we're going to do is do the following. Okay, first we want to create a slice. So first what we'll do is we'll say const thinking about how I want to do this because technically on the first one, so it'd be up to 0. Okay, I think I can come up with a formula for this. Okay, so slice equals, and then we're going to take the original array of nums, and we're going to want to slice some of that array starting from the index should be whatever the, okay, the number is. So let's see here, 10 million. Okay, starting with 10 million times ours dot length. Because again, on the first one, that would be 0. Ours dot length. Oh, I see, I wrote an X. Okay, so on the first one, that'd be 0. When it's 1, that would be 10 million. Okay, so that would be where you start slicing, and then you would start slicing up to, but not including, ours dot length plus another 10 million. Okay, so we need 2 more zeros there. Okay, cool. Okay, so they theoretically, again, so on the first scenario, let's just kind of think through the math. So it would be 10 million times 0. Okay, so the starting index would be 0, and it would go up to index 0 plus 10 million, so it would be up to 10 million. Then the second go around, 10 million times 1 would be 10 million, and then it would be from 10 million to 10 million times 1, 10 million plus, yeah, so that math works. Okay, so that'll determine the index of where I'm slicing. Okay, And then what I'd want to do, okay, is then I would then push that array, push rs dot push, and I'm going to push that into rs. Because basically what I'm doing is I'm breaking up the array into a bunch of smaller arrays. So this would represent like, hey, I'm going to distribute this work across, the chunks of work I'm going to distribute across many threads. Okay, yes. Okay, and then basically once we have 6, we should have, because again, the first one should have 0 through 10 million, the second one should have 0 through 2, third one should have 0 through 3. Yeah, that works. Okay, so let me just first confirm that that works. Console.log.rs. Okay, and again, we're going to be timing this as well. So console.time, and this is going to be the whole MapReduce process. Dot time end MapReduce. Okay. Okay. MapReduce. Okay, and the MapReduce so far, just generating the data, resulted in. Okay, and then we got this sort of interesting array. And what happens if I just print out the first item from the array? Just curious. Or second item from the array, technically. Ref times 1. That's not what the code says, though. It's saying it's circular, so that means it's like self-referential. So something didn't go right there. Nums.slice. So we're slicing a piece of that array. Oh, it's because I'm pushing itself in there. Oops, I'm not pushing the slice. There we go. Okay. Okay, cool. Okay, so that's looking like the way it should. Okay, cool. So the idea is, now that we have the sets of data, what we can do is we can try to have them all, instead of processing them all at the same time and waiting for, you have to wait for the first 10 million, then the second 10 million, we can use promises to have them all kind of going concurrently. Okay, so what we'll do is we can do this. We can say, okay, for let nums or r of r's. Actually, no, we want to do MapReduce. So let me see here. So const result is going to equal. We take first one to do a map r's. Okay. R's dot map. So we're going to map over each item. Okay, so each array gets mapped over. And what we want to do with each array is we want to put it inside of a promise. So that way it delays it. So we're going to create a new promise. So we're going to return a new promise. The new promise is going to receive a callback with resolve and reject. So we just need to define that. Okay, so that's what the map is returning, a new promise. And each promise should then do its own map. So basically each map is going to resolve the result of, nope, resolve, okay, there was a response here, resolve, and the amount it's going to resolve is the return of that particular array dot map, and then we take each item in that array and return x plus 1. Okay, cool. And that's going to happen to each one. Now what's going to happen is that then we're going to have this array of promises, which I'm going to want to reduce into a result. So map, then reduce. So now I want to take that array and turn it into one end result, which I didn't do here. All I did was add 1 to all of them, and I had the array. What I didn't do was add. So let me actually add that to the first operation. So no reduce, we map the array, and then we would want to reduce it. But here we're just doing it as a big chunk. So first we map array, and then we're going to take the basically what it is, it's a function that takes the accumulator, and then the number, and then we just basically always want to return the accumulator plus the number, and then we want the accumulator to start at 0. Okay, so let's see how long it takes to first generate the array and then add them all together. Okay, so that's the sum of all the numbers. Okay, and it took about 2.5 seconds to do that. Okay, so again, starting with just an array of 60 million numbers, it took 2.5 seconds to again add 1 to all of them and then add them together. So now we're going to kind of do the same thing here, except we broke it up into 10 subarrays, and we're using promises to do each chunk separately. So that way they can kind of happen concurrently. Because again, a promise will be delayed, and then we'll come back and take a look when the promise resolves. Okay, so basically we're doing each chunk. Okay, and technically I should probably do that second half of the reduce there too. So I should probably also reduce here, kind of add each chunk while I'm at it. Reduce x. Again, it's just going to be ac num, and that's going to return ac plus num, and then we start the accumulator at 0. Okay, so essentially we're doing that same operation, but only on a chunk of the full set of numbers, so that way you can have like 10 operations kind of going at the same time. So that's going to give me a sum for each chunk, and then what happens, I want to have an array of numbers, which I can then do the final reduce for. So reduce dot, and then again, I would just say ac num return num plus return ac plus num colon 0, close the parentheses. Okay, so this should return me the same amount, but again, I'm doing it by creating a promise for every 10 million numbers. I'm kind of grouping the operation of those 10 million separately instead of doing it all as one big continuous accumulation. So let's see if it saves us any time. Okay, and again, that should get us the same result. So if I console log result, I should have the same number if I did this right. I don't need the console log from here, so we can just get rid of that console log. Okay, so the first process took 2.7 seconds. And yeah, so you see like but it didn't give us necessarily the right result. We got a bunch of promises. And here's why. I forgot to resolve the promise. So what I should have done is do this. Make this reduce an async function, because again, it's reducing an array of promises, and then I should be awaiting the num. Okay, because I'm waiting the result of that operation. Okay, new promise resolve. Yeah. Okay, so now if I try that again, let's see if that gives me the right result. Okay, see that time it took longer with because it's also going to return a promise. So what I have to do here is we want to do like a result dot then result r console.log r, so we can actually see what r looks like. Okay, let's try that again. So the first one took 2.7 seconds, and the second one took 2.578 seconds. Although that does not look like the right number. It's like, wait a second. So this makes me want to break this up a little bit. Okay, so let's first take this, make this result like, p's, meaning for promises, plural. And then what I'm going to want to do is console log p's, just to make sure that I'm doing this right. Console.log p's. This should be what I think. See if this is what I think it is. And let's then say, okay, const result equals p's dot reduce. Okay, so that time it took 2.1 seconds. And again, the reason why it's going to vary is because the JavaScript engine does do some caching of some of these operations. Okay, cool. So then, since we're going to add up all those numbers, and then, okay, so then we're running into an array. So let's just see here. Kind of have to take it on gospel that that's the right number, but let me just think about that for a second. So let's see here. Taking the slice. Okay, and just to double check if my slices are right, let's console.log each slice's length. Make sure that I'm basically like the slices, I'm slicing this thing right. Okay, so yeah, I'm doing 6 slices of 60 million. Although that sounds like a lot more than that should be. Well, I guess not. I guess that makes sense. Although this number does not make sense. It's only giving me the last promise. Oh, wait, that's only giving me the last promise. Okay, so let me go take a look at my reduce here. Return the accumulator plus await num. So let's change this function up a little bit. Okay, so each time I want to console log the accumulator, let's just put a little label there so I can see what this console log is doing. Okay, because technically what I want to do is always return the accumulator, which on the first one should be 0. But then I want to add await num. Okay, and then I'm also going to console log num to confirm that it is a promise. Console.log num num. So let's run that. So the accumulator is a promise each time because the function's async. So that is probably part of the issue. So I wonder if I put await in front of both of these, if that fixes the problem. Okay, there we go. Now we're matching numbers again. Okay. So, looking at this, now let's get rid of some of these extra console logs, so that way we can shorten up this operation. See what it's actually taking. And let's see what the time difference is between the two. So the first one took 2.8 seconds, and the second one took about 2.8 seconds. Again, you're not going to save too much time here because technically JavaScript is still single-threaded. I could again pass these off to child threads. That gets a little bit even more complicated, but theoretically that's the whole idea behind like the divide and conquer strategy. So what I would have done is broken up those 8 arrays, okay, or those 6 arrays that I did in the second operation, and then passed them off to either like another thread, another core on your processor, or even to a whole other node on a cluster of computers, and then each of them would do their operation on all the items in the array, and then we would reduce all those values together, and thus the MapReduce pattern. Okay, and this is essentially, if you ever hear about something called Apache Hadoop and MapReduce, that's what it did. Okay, and then frameworks like, and then other multi-node processing frameworks like Spark, Dremio, that let you query data on a cluster of computers. That's essentially how they work. They're going to break up the data, distribute it across several computers, and say, okay, you do the thing to each item in the list of items, and then give me back your end result. Okay, and then what we're going to do is we'll then reduce those arrays into one big array. Okay, that's essentially what we did here. Okay. Yeah. Okay. That got a little bit more complicated than what I really wanted to kind of illustrate, but I think if you sat through this whole thing, you probably got a few cool things out of it. And uh, yeah, um, I'll leave it at that. But hopefully, I got you thinking about sort of like different strategies when you're coding. My name is Alex Merced from AlexMercedCoder.dev. Have a great day and enjoy.